This is Josh White with JW Math Tutoring. In today's video, I'm going to cover 11 problems from the May 2025 Digital SAT Math exam. So let's go ahead and take a look.
But life is a dream the calculus could never predict.
Just before I get started going through these problems on this second May 2025 Digital SAT Math official test questions worksheet, I want to mention a couple things. Of course, if you like this video, please give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, I have compiled these primarily from Reddit based on what students who took the May 2025 exam reported. So some of these questions might not be exactly what you have seen on the test. You know, the wording might be slightly different. There might be some details that are missing. I've tried to recreate them as best as I could, though. So please keep that in mind. Also, some of them will be done as free response, you know, basically the student-produced response, rather than multiple choice, even though on the test they may have been multiple choice questions. Okay, so just be aware of that. And related to that, there might be additional solution methods you could use if a question was multiple choice, as compared to just being, you know, a strict kind of free response type question. What else? Oh, I also want to mention the link to these problems for the PDF file will be in the description of the video and also in the pinned comment. Be sure to check out the videos for worksheet number 1 and worksheet number 3 as well. And I think with that being said, let's go ahead and get started. So this first problem here, you know, problem number 1, basically is a repeat of a Blue Book practice test question. It is from practice test number 4. And it's the problem of the two rectangular prisms essentially being stacked on top of each other. Now, technically, in that question, they do not specify that the two prisms are stacked vertically. Like, they technically could be slanted, but whatever, ignoring that. What they intended, you know, is for the two things to be stacked vertically on top of each other like this. All right, so we know that the height of one prism is here 90, okay? And we know that the surface area of a base, which is a square, is just k. Now, you're also told that when you glue the two prisms together, you know, directly on top of each other, the total surface area for both prisms, by the way, sorry, this is wrong. This should be surface area, not the area of the base. I was misreading what I had typed out here. It has a square base, but the surface area of one prism is just k. All right, when you stack them on top of each other, then the total surface area becomes this 63 over 36k. Note, this is the only fraction I could get to work without just, you know, reusing the same fraction that they did in the Blue Book question. So this is going to be a slightly different problem. But what we want to find is the side length of, you know, the base, which is a square. How long is each side in the base? All right, so first I'll show essentially the two equations you would set up, and really you're going to set these two equations equal to each other, and then to solve them you can actually just do that whole thing in Desmos. So basically the surface area of one prism is going to be as follows, and I'm going to use x for the length of the sides of the base. All right, so basically one prism, a rectangular prism, it has 6 total sides, you know, a top, bottom, left, right, front, back. So top and bottom, there's going to be the bases. Their area is going to be x squared, and there's 2 of them. Okay, so we have 2x squared. Then the front, back are going to have sides of 90, because the height is 90, and another side of x, so 90x. And there's 2 of those. There's also a left and a right. Their area is going to be identical. It's also going to be 90x because the base is a square. So there's really going to be, you know, 90 times x, or 90x, is the area of like one kind of face, and then there's 4 of them. There's front, back, left, right. Okay? that is equal to k. Area of the two bases plus the area of the four, what you could say vertical sides in my picture, that equals k. All right, now just before we begin, I'm just going to, by the way, simplify this to 360. All right, so that's our one equation. Now, the second equation is the area of the two prisms stacked together, which is basically going to be two total bases, because you're going to have the base on the very top and the base on the very bottom. The other two bases are not counted because they're kind of covered up when you glue them together. So these two other bases, we don't include, we don't count them, don't include them. So we have 2x squared from the very top and bottom. And then there's multiple ways you could think about this. I mean, if you wanted to think about this as technically one unit, basically you have four sides again, and each side now has a width, or what do you call it, length of x, but now a height of 180. So you could say 180x is the area of like one of these large faces, and there's four of them. Front, back, left, right. They're all identical. Okay? So that's equal to 63 over 36k. Now we could just go ahead, and I'm just going to simplify this to 720. We want to solve this for x, so ideally what we're going to do is we're going to basically get each of these equal to k, then set them equal to each other, and then that expression I'm just going to go to Desmos and plug it in there and solve it all out. So I'm going to multiply both sides by 36 over 63. By the way, that fraction can be reduced if you want to, basically divide each thing by 3, but I'll just leave it like this for right now. So when I do it on the right side, multiplying by 36 over 63, cancel, 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 and that gets me just equal to k. So now what you can do is you can set these two equations equal to each other. So we have 2x squared plus 360x equals 36 over 63 times 2x squared plus 720x. We don't want to waste time or bother solving this out by hand. So like I said, I'm just going to jump to Desmos and find the solution in there. Now, this one, let's see. I'm going to try typing it as just one equation, setting everything equal to each other, and trying to get the solutions that way, rather than doing y equals left side, y equals right side. So when I do that, okay, there's one answer, which is 0, so that doesn't really help us. Is there another answer out there? Yes. Yes, there is. It's right here. The answer is 60. The length of each side of the square base is 60 in this example, basically that, where I created the numbers. That's what you would grid in, or if it was not grid in, type in. If it was a multiple choice, of course, 60 is what you'd select for your answer. Now, I will show you an alternate way to set up the second equation, which is a little bit simpler and a little bit easier, and it's actually not too bad to solve by hand. So this equation, this first one where it's equal to k, we're going to keep that. But now, an alternate way to think about this is basically, okay, 63 over 36k. That's the total surface area of two prisms stacked together. You could also say that the total surface area of two prisms stacked together is 2 times k, because k surface area for one plus k surface area for the other, and then you just subtract from that the area of the two inner bases right here that we don't count. And the area of those two bases, the bottom from the top prism and the top from the bottom prism, is minus 2x squared. So now, what you could do, let's see, how did I do this? I think I just went ahead and basically got 2x squared on the right, and then on the left side, this actually, I mean, you can do this in Desmos, but, this is just 72 over 36. So when you subtract this over, it just becomes 9 over 36, which is really 1 over 4. And then, so also need a k here. And then you could just multiply by 4 and get k equals 8x squared. And then you could just set that equal to the original equation, meaning this 2x squared plus 360x. So that is actually not that difficult to solve. 8x squared equals 2x squared plus 360x, because you just get 6x squared minus 360x equals 0. And then we just factor out a 6x, and you get x minus 60. So x equals 0, x equals 60. Obviously, 0 is not correct. So that's just an alternate approach you could take to set up the second equation. But since we're solving the problem in Desmos, you don't actually have to bother going through all this solving. But that's just, again, an alternate way to think about setting up the equation, where you're finding the total area of both prisms together. All right, the next question, number 2 here. You're given an exponential function, and you're basically asked, what does the 5/4 in this equation, in this function represent? Now, technically, I just put these things on here as like 1.25 instead of 5/4, but they're the same numbers. So what does this 5/4 represent? Well, since it's an exponential function, that's how much the output, in this case the f of t, is increasing by whenever the input, in this case t, increases by 1. So when t increases by 1, which means an increase of 1 year, the output, which is the total number of reindeer, is basically going to be that many times greater. Okay, because it's exponential. It's not linear, that's why it's not increasing by a certain number, but it's, basically being multiplied by that value. So if you go through these answer choices, okay, A is obviously not wrong, is obviously wrong, is obviously not correct. That's what I was trying to say there. And B and C, these are, essentially if it was a linear function, increasing or decreasing by a specific number of reindeer per year. And of course, we don't even talk about, whatever, 1.25 reindeer, fractions of a reindeer. So the correct answer for this one is obviously D. Each year that goes by, when you increase the t-value by 1, the overall population is going to be 1.25 times larger, 5/4, times the value, than it was the previous year. So correct answer for this one is just D. All right, next up, question number 3. Here we have a right triangle. Okay, triangle X, Y, Z. They tell us X is the right angle, so let's put Y up here, and let's put Z down here. And then we draw XW, which is perpendicular to YZ. So basically we're drawing the altitude to the hypotenuse. Common scenario, common problem type that you see. And WX, so this altitude right here, is 477. And YW, so this little part up here, is 636. All right, find tangent of angle Z. So Z is right here. All right, here is the thing basically to know or be aware of. So when you draw this altitude to the hypotenuse of a right triangle, it makes now 3 triangles. We've got the large and we've got 2 small. And they are all similar to each other, meaning they all have the same congruent angles, and therefore they are all going to have the sides matching, the corresponding sides matching up in the same ratios. And that's how we're going to find tangent of Z, even though we don't know, YX or XZ. Okay. So just to try to simplify this, I am going to fill in some angle measures, and these are most likely not the correct angle measures, but I'm just going to do this to kind of help demonstrate, matching up with the corresponding sides. So say that this angle up here was 40 degrees. Then in this overall right triangle, Z would have to be 50 degrees. That would also mean that since this is a right angle here, in the small triangle on the bottom, this would have to be 40. And then, of course, over here, if the whole thing's 90, this would have to be 50. The reason I do that is so I know how to draw the 2 small triangles to match them up with their corresponding sides. So for example, here's W. Okay, I'm going to put X at the top, and I'm going to put Y down here. So this triangle that I just drew is this right here. Okay, so YW 636, XW 477. Okay, and just in, again, these are made up angle measures, but I'm just using them to help match things up. The 50 goes up here with X, the 40 goes down here with Y. All right, now let's look at the one at the bottom. So again, W is where the right angle is, so that's going to be down here. The angles have to match. So I'm going to match it. The 40 is going to match down here, and the 50 is going to match here. Okay, the 50 is where the Z is, so Z is going to go up here, and the 40 is where X is, so X is going to go down here. Now, let's see, what else do we know? We also know XW right here is 477. Okay. Let's just make sure. Sorry, I'm just checking my picture. Yes, making sure everything matches up. All right, so notice that Z and X are the corresponding angles. Therefore, because these are similar triangles, the tangent of Z is going to be equal to the tangent of X because they're both going to be the same angle measure. So therefore, the ratio of their tangents are going to be equal as well. So the tangent of X is equal to its opposite over adjacent. So the opposite here is 636. The adjacent is 477. Therefore, this you can just plug into Desmos. I'm going to show you it's going to reduce to 4/3. And that's going to be our answer. Oops, why am I putting it on a second line here? Right there, 1.33333 repeating. But we click this and we just get the fraction of 4/3. So the tangent of angle Z is equal to 4/3, or you could also type in 1.333. And that's how you can get the answer to this problem. You do not need excuse me, to solve for any additional side lengths. I mean, you can like use trig to find out what the actual angle measurements are here, and then, you know, go from there. But actually, let's do that. Yeah, let's do that as a secondary kind of like alternate method, just to show you that it could be done that way as well. So let's erase this. Let's erase all this. Okay. All right, so excuse me. We look at this triangle up here at the top. Basically, you know, XWY or XYW, whatever we want to look at. I'm gonna look at angle Y right here. And I'm going to say, okay, tan of Y is equal to opposite 477 over adjacent 636. Just confirm, yeah, neither of those are hypotenuse. Hypotenuse in this top triangle is XY. All right, so now I can just do inverse tan of that. 477 over 636. So let's go to Desmos. Okay, we're in radians, so we need to click the gear thing here. Change to degrees. Okay. So we've got this specific value for Y, for angle Y. So I'm just going to define that. Okay. 36.87 approximately. So now I can just subtract from that from 90 to get the measure of angle Z. So let's go to Desmos. 90 minus Y. Okay, so this is the measure of angle Z right here, 53.13, but I want to use the exact value, so I'm going to store it in. 53.13. Okay, and now what's tan of Z? Well, all I have to do is just now do tan Z. And right there's my answer, 1.3 repeating, because I used the exact values and carried them through, or 4/3. So maybe you think that's easier, you know, using basic trig, and that's fine if you want to do it that way as well. That's just an alternate method you could use to solve this problem. Okay, now next, top of the next page, question number 4. So you're told about this plant that's growing at a rate of 2.5 inches per year, and then you're told that the second plant is growing at a rate which is 33% less than the rate of this first plant. So how do you classify the growth of this second plant? Is it increasing exponential or linear, or decreasing exponential or linear? All right, so first of all, hopefully you notice it's going to be increasing because even though the rate is 33% less, it's still growing. It's still, the height of the plant is still increasing so many inches per year, just like, this first plant is. So we can get rid of C and D right away. And the answer for this one is going to be letter B. It is increasing linear because even though we see a percentage here, so like plant A, 2.5 inches per year. Okay, plant B is 33% less than that. So we take 2.5 and we subtract 33% of 2.5. And when we do this calculation, it's going to come out to, I think, approximately 1.675. Yep. So that means the second plant is growing at a rate of 1.675 inches per year. This is still a linear growth rate. It's a fixed number of inches per year. It's not increasing by a percentage or by a multiple. So even though you see a percentage in the problem, the answer is still increasing linear, letter B. Okay, next up, we have a formula problem. Question number 5. We've got X, Y, and Z here. First, I will show you how to solve this by hand. Then I will show you how you could do this in Desmos. Now, of course, on the test, this would be a multiple choice question. There's no way to type in the formula answer with all the different letters and stuff. But I'm just going to do it as a free response. Excuse me. I'm just going to do it as a free response question. And because obviously I have the correct answer to it, but I didn't have all the other answer choices, so I didn't bother creating them. Okay. So if we want to solve for x, first thing I'm going to do is clear out all the denominators. So I'm going to multiply by the common denominator, which is going to be 42, because I need a 6, and I need a 7, and I need an x, and I need a y, and I need a z. So I'm going to multiply by that on both sides. Okay, on the left side, the x and y are going to cancel. I'm going to be left with z, and the 6 goes into 42 7 times. Then multiplying by this middle term, nothing's going to cancel. It's just going to be 42 x squared, y squared, z squared. On the right, x and z are going to cancel. You're just going to have a y, and 7 will go into 42 6 times. All right, so we end up with this. Now, excuse me. We want to solve this for x. So if you notice, there's only one term that has an x in it. Okay, it's this like x squared, y squared, z squared term. So I can move the 7z over to the right. And then we can just divide by 42y squared z squared. Okay, so now when we do that, on the left side I have just x squared. On the right, I've got my 6y minus 7z. It's not 72, but 7z. Over the 42y squared z squared. And of course, the last step, you can just square root this. So I'm going to assume that the answer the answer they have listed is just like the positive in front of the square root, but you could also put a negative in front of the square root as well. Technically it's plus or minus when you introduce the square root, so either it could look like this or it could look like this. Either one would be acceptable, but basically you're going to choose the multiple choice answer that, say, would match this expression here. Now, let's see how you could do this in Desmos. Okay, so first thing I'm going to do, I'm going to type the expression in, except I'm going to replace y with a and z with b. I will leave x in the expression, the equation as normal, though. Okay, excuse me. Notice here, so far, nothing is shown up on the screen, right? So we got a little bit of a problem. However, if I move some values here, notice I get some solutions. Okay, so let's see. All right, so both values are still positive, and again, I don't know what restrictions they would have on the values in the problems. Obviously, they can't be, none of them can be 0. You can't divide by 0. But other than that, I don't know if they would restrict them to only positive numbers or, whatever. But in any case, here are some solutions. This is what we're looking for. So now what you would do is you would go through each answer choice and you would type it in. You type in x equals, and you have to remember, replace y with a, replace z with b, and then you're going to see which answer choice has a vertical line overlapping one of the given existing lines we have on the screen. So notice when I do that here, this is overlapping the right one, or the positive, 0.77892. And of course, if I just made this negative, then it just switches to the one on the left side. Okay, but this is just confirming that this is the correct expression, the correct answer when you solve this for x. Again, just remember I had to replace y and z with a and b, and then just set them equal to whatever values. I guess technically you don't have to replace z. It's really the y is what you have to replace with a different letter that as a constant that you can just define a number, define a number for. Okay, next up, question number 6. Here you have this one has two groups of penguins. One of them has a given mean, another one has a different given mean, and the question asks for what the combined mean is, basically of all the penguins, together of both groups. Okay, so really what you're doing here is a weighted average. And so all we're going to do for that is you take the number of penguins and their mean and multiply them together. That essentially gives you the total sum of all the heights. And you do that with the second group as well. Number of penguins times the mean. And then you just divide the total heights from both groups by the total number of penguins, which is 340 plus 170. That's just going to be 510. Okay, so you could just go to Desmos, punch this in, and we get 90 as our answer. So the average height, the mean height of all 510 penguins from both groups is 90 inches. Now, you could also do this entire thing in Desmos. You basically just putting the data into a frequency table. I'll just show you real quick what that would look like. The y values, the y column are the frequency values. So that would be 340 and 170. And then the x column are your actual, mean values or your measurements. So the 88 and then the 94. Okay, and now what you're going to type in is total x1 times y1. That is basically going to multiply across each row and then add the values up as you go down each row. And then you divide that by the total of y1, which is the sum down the y column for the total number of penguins. So notice we get the exact same answer, 90, but again, this is how you could just make a little table, really it's a frequency table, and then just you type this in and it gives you the answer right away. All right, let's look at question number 7. This is a repeat question. We have seen this one before. Basic on official tests. Basically, you have two lines that are intersecting. Maybe like something like this, and you have two acute angles and two obtuse angles. Obviously, these are the obtuse. These are the acute. All right, and you're given an expression for one of the acute angles, right? So 9x plus 280. You could also put this down here. And basically, like what it's wanting to know is, one of these expressions you cannot form or cannot make by adding any two of the, 4 angles together. 3 of them you can, 1 you can't. Which is the one that you can't? Now, to get an expression for the acute angles, basically you're just going to do 180 minus, the 9x plus 280. So when you do that, it just simplifies to negative 9x, and then 180 minus 280 is just minus 100. Okay? So now, really what all you're doing here is you're like adding up all the various combinations. So if you add up these two, well, it's 18x plus 280 plus 280, which is 560. All right, this one's out. Notice if you add, obviously, across a straight line, one obtuse and one acute, that's 180. That one's out. And then if you add up two of the acutes, basically you're going to get negative 18x minus 200. Okay, that one's out. Correct answer is going to be letter D here. Now, an alternate way, excuse me, that you could do this as well is you could let x equal negative 20. Okay? And so notice if you do that, okay, then the original there we go. The original obtuse angle works out to be 100, which matches, and that means the other one turns out to be 80. So if you want to work with actual numerical values, well then you could just say, okay, 100, so 100 plus 80 is 180. Okay, that's obviously out. 100 and 100 is 200. So we got 100, we got 200, we got 180, we already confirmed. We have 80 and 80 is 160. So then you just go to the answer choices and you just type them in and you see, well, if x is negative 20, so for the first one, okay, the first one equals 160, so A is out. The second one, which is 18 times negative 20 plus 560 equals 200, so that's out. And then if you check the last one, well, that's negative 80. That doesn't make any sense. So D is obviously just confirmed that that's the correct answer to the problem. That's the one that basically cannot happen. So again, you could pick a value for x. You could plug it in, just make sure it works, and then you could go through and actually add up, numerical values instead of expressions if you want to. All right, next up, question number 8. They love this problem. I don't know why. It's a word problem, but it's on the Blue Book practice test. It's on the official test almost every single month. It's the whole thing where, something costs whatever dollars for the first, 3 hours or 4 hours or 10 people or whatever it is, 20 people, and then the total cost for 5 hours or 6 hours or for 50 people or whatever is this much. And they want to know the equation that gives the total cost for, X hours of work or for X people or whatever. So a lot of people would see this 290 here and they would automatically jump to, letter B as the correct answer. But that is wrong. That is incorrect. First, I'll show you the actual way you could set up the equation, then I'll also show you how you could back solve it. So notice, to begin with, for 5 hours, it's $500. However, the first 2 hours are $290. So if we subtract that, that means it's $210 for 3 additional hours. So if you divide that by 3, you get $70 per hour. Okay? That should help you eliminate D, and notice that it's either going to be A, B, or C. Because $70 is the amount that each hour, the change in the cost per hour, essentially the slope. So now, when you set up the actual equation, it's going to look like $70. Now, it's X hours of work, but you actually plug in is X minus 2, because the first 2 hours are already accounted for in the 290 that I add on the end here. So this is the original equation you set up. Then when you simplify it, distribute the 70, it then becomes 70x plus 150. And so the correct answer becomes letter A. Now, an alternate way you could do this is you could pick values, pick numbers basically for x. So like say x is equal to 4. If it works 4 hours, how much does the job cost? All right, so it's going to be $290 for the first 2 hours, and you do have to figure out the hourly rate in order to take this approach. So you do have to figure out that it's $70 an hour, and then you would say, okay, plus 70 or plus 70 times 2, because it's 2 hours. Therefore, we should get, what, 430 as our total cost. So now you go through all the answer choices and you just plug in 4 for x, and you see which of these equals 430. Okay, it's going to be A. B is going to be 280 plus 290, which is 570. Wrong. D is going to be 100 times 4, which is 400. Wrong. C is going to be 280 plus 500. That's going to be 780, which is wrong. So again, it just confirms correct answer is letter A. All right, next up, let's talk about question number 9. This one was on the Blue Book practice tests when they changed practice tests 1 through 3 last summer. They updated them. And then when they came up with the new practice tests and they retired 1 through 3, I believe they removed it or got rid of it, if I remember correctly. Anyways, you have a bunch of functions here. When you increase x by a factor of c, the function increases by 27. Which equation has 1 over c as the coefficient of x? All right, so there's two different ways you could think about this. Here's one way. You're looking for 1 over c as a coefficient of x, right? Okay, so that means if you go through each of these, in the first one, the c has to be 2. In the second one, the c has to be 6. In the third answer choice, c has to be 4. And in the last one, c has to be 3. So let's just go to Desmos and see, okay, if we increase the function by those values, does the answer increase basically by 27? And actually, I should probably word this. I should actually probably word this a little by. It doesn't increase by 27. I'll fix this in the PDF. Basically, increases by, I'll have to look at, see how it's worded on the practice test, by a factor of 27. Essentially, we're looking for it being multiplied by 27, not just adding 27. Okay, so I'll look up at the I'll look at the wording from the Blue Book test and fix this again, like on the PDF file, just so the meaning is clear. All right, so if we look at the first one, 3 to the 1/2 x. All right, so here's the function. So what I'm going to look at, basically what I'm looking at is, okay, let's say I start with f of 0, and then I increase by c. So 0 plus 2 is f of 2. All right, what I'm looking at is, did the function increase by, again, a factor of 27? Meaning, if I take f of 2 and I divide it by f of 0, do I get 27 as my answer? No, I do not. Therefore, that is not the correct answer. Now we can repeat the process with answer choice B, and all I have to change here is make this to the third and make this 6. Now, actually, no, sorry, I do have to change this. Now, I'm comparing f of 0 to f of 6 because I'm increasing x by 6, by a factor of 6. So this becomes 6, and let's make this 6. Notice when I increase my x value by 6 from 0 to 6, the output, f of x value, has gone up by a factor of 27. That confirms this is the correct answer. The correct answer to this is letter B. And you could check C and D. I'll just do C, won't bother spending time on D. So I got 9. I'm going to make this a 4. Now I need to change this to a 4. Now I need to change this to a 4. Okay, it's 9. It's not 27. That just confirms that it's wrong. So that's one approach. Okay, here is a second or alternate approach way to think about this problem. And let me just erase this. Okay, basically, you want each of these functions to increase by a factor of 27. That means you want all these parts that I'm putting inside the brackets to increase by 27. Okay? Like the 91 is just a constant out front. You know, we're really looking at like what is the value which causes it to increase by 27. So, essentially what you're doing is you're trying to turn that into a 27. So, like if you think about this for this first one, right? Like, in order to make 27 here, you basically need 3 to the third. So it's like, what value do you need to plug in here for x in order to make this 3 to the 1 half x, or x over 2, equal to 3 to the third? Now, let me just actually change this to 27. Okay, you could actually just do this really quickly and easily in Desmos just to find all these values. So for example, I have 3, and I'm just going to use c. 3 to the 1 half c, and we want this to be equal to 27. Okay, c equals 6. And then if we look at the next one, 3 to the third. All right, I gotta. I need to put a parentheses here, and then I need to raise this again to 1 over 6, and then the c, and I want to equal to 27. Okay, notice it's 6, and I'll just tell you the pattern is going to be for all of these, the value that all of them are increased by, or the x is increased by in order to increase the overall function by a factor of 27 is going to be 6. That's just how these are all set up. C, for this one for C, when I type it in, again, C is 6, and it's going to be true for D. So now you could just, so once you confirm that, then you just go through and you see which one has a factor of 1 over C, or 1 over 6, in front of the x. As a coefficient on the x, well, it's obviously letter B. So this is just an alternate way to think about it. The first approach, I took the answers and I said, what would the c value be based on this problem? 1 over c. What would the c value be? And then I checked and I saw which one was correct. An alternate approach is take each equation, find what the c value has to be, which for all of them is 6, and then just look and see, okay, which one has 1/6. So however you want to think about it, 2 different ways you could do this problem. All right, top of the next page, we have question number 10. This is a repeat question, appeared once before previously. Basically, it's a percentage problem, and so what's happening here is this expression kx represents decreasing x by 0.34%. All right, what's the value of k? So if you have x and you decrease it by 0.34%, that's the same as decreasing it by 0.0034 times x. So what is this equal to? Well, you basically just go to Desmos and just do the subtraction with the coefficients. 1 minus 0.0034. It's 0.9966. So this is equal to 0.9966x. So what's the value of k? Well, k is just this number right here. So you could grid in 0.9966. You could technically grid in 0.996 if you truncate it, or you could also grid in 0.997. Okay, so all of those would be accepted, as correct answers. It's basically saying if you decrease x by this percentage, it's the same as multiplying x by what number? That's really what this problem is asking. All right, let's look at the last question. System of equations that has no solution. It has a constant in one of the equations. What's the value of p? All right, so first I will show you how to do this in Desmos because it is incredibly quick and easy. However, before we do that, you do need to have all of the variable terms, in this case r and s, or x and y, whatever they are, on the same side for both equations. They don't need to both be on the left or both be on the right, but it's just in each individual equation you do need to have all the r's, all the s's on the same side. So I'm going to subtract this over and just get 2/3 r minus 5/2 r plus 3/2 s equals -10. And in the bottom one, I'm going to subtract this over. ps minus 3/4 r equals 5. Okay. So now we can go to Desmos, and all we're going to do is I'm going to type the coefficients for the r, which is basically say that's our x. So there's two terms, so I have to do 2/2 minus 5/2. And I'm going to divide by that the coefficients for the r term in the denominator, which in the bottom equation, sorry, which is negative 3/4. Then I'm going to set a regression, use a tilde. Now the coefficients for the s terms, or our y terms, from the top equation divided by the coefficient for our s term in the bottom equation, which is just p. There is our answer, 0.613636. Okay, let's type it. Let's convert it to a fraction. It's 27 over 44. So 27 over 44, correct answer, 0.6136. Correct answer, 0.613. Correct answer, 0.614. Top one's truncating, bottom one's rounding. All of these would be accepted as correct for this specific problem. Now, lastly, I'll just show you how to do this by hand if you wanted to. So, first one, I would multiply by 6 to get rid of all the fractions. That's going to give you 4r plus 9s equals 15r minus 60. And then the bottom, I would actually not do anything, because all you have to do to solve that for s is just divide by p. So you get 3 over 4p r plus 5. Okay, so that one is solved for s, which is just say like our y. So I got to solve the top one for s. So 9s equals, subtract this over, minus 4r, you get 11r minus 60. Divide by 9. All right, so now we can match up our slopes. Basically, we can say this is no solution. Both lines have the same slope. Therefore, 11 over 9 is equal to 3 over 4p. Cross multiply, 44p equals 27. Divide by 44. P equals 27 over 44. This is how you could solve it out by hand. All right, so I hope you enjoyed this video. It went a little bit longer than the first one, but that's because there's some complex problems and also some alternate solution methods. If you did like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Again, check out the video for worksheet number 1 and also worksheet number 3 as well. If you have any questions or comments or alternate solution methods, please do leave them in the comments below. And lastly, of course, if you are looking to improve your knowledge of Desmos, please go ahead and check out my Ultimate Desmos Guide to Digital SAT Math. It's over 3.5 hours of tips and tricks, and we're up to now over 50 example problems, including many advanced techniques using regression to solve all kinds of problems, just like this last one, here, number 11.